Hello and welcome to this lesson about greatest common factors. The learning target for this video is finding the GCF between two or three numbers. So first, let's talk about what the GCF is. So GCF does stand for greatest common factor, and what we're referring to for greatest common factor is the largest shared multiplication building block. So we're looking between two numbers and we want to see what is the largest thing that they share if we're breaking apart all their factors. So that's what the greatest common factor is. Now, how we go about doing this for the process, it's all about breaking it down to its prime factorization. So breaking numbers into their prime factorization. Prime factorization. And then what we're going to do is circle and multiply. Circle and multiply. What's that here? Circle and multiply all the shared factors. So let's do some examples. And let's start off with something pretty straightforward here. So examples, let's say we have something like 16 and 20. And we want to find the GCF of these two numbers. Well, what I'm going to do is break down each number. So 16 is 8 times 2. And then that gives me 4 times 2 and 2 times 2. So I now have the prime factorization of 16. Then I go to 20 and I'll go 5 times 4. And here I'll get 2 times 2. So now that I've broken it down to its prime factorization, and for this one it might seem somewhat simple. Some of you might be able to watch this and realize it's 4. That's just, duh, that's how it is. But the process is very key for when we have to deal with larger numbers and we don't know right off the top of our head. So we break it down, and now we find the ones that are shared. So there's a 2 that is shared with the 16 and a 2 that is shared with the 20. There's another 2 that's shared with the 16 and another 2 that's shared with the 20, and that's it. There isn't any more. So now that we've circled the shared ones, we multiply them together. So the GCF is equal to 2 times 2, which is 4. All right, now let's do another one. So another example here. Let's do something with a little bit with bigger numbers. 54 and 72. So here we want to break them down. And so I know that 54 is 9 times 6, and then 9 is 3 and 3, 6 is 3 and 2. 72 is 9 times 8, and then again we have 3 times 3, and then we have 4 times 2, and then this 4 becomes 2 times 2, and we now have them both in their prime factorization. So the GCF is equal to, well, they both share a 3. They both share actually 2 3s, and they share 1 2. So we have 3 times 3 times 2. And that's equal to 9 times 2, which is 18. And again, this is another reason why going through this process is actually really good for you, because you might see 54 and 72 and think 9, duh, I mean, they're both, 9 times something. But by going through and looking at all the prime factors, now you see that, hey, maybe there's something else that they share in common. You see that extra 2 that maybe you didn't think of off the top of your head, because people don't know the multiples of 18 off the top of their head. All right, let's do one more example. Let's say now we want to find the GCF of 3 numbers. So what we can do is, again, keep breaking it down. Now, one thing that might become a bit of a shortcut that's helpful is maybe you recognize a common factor off the top, or right off the top. So, for example, I know 12 is a common, or is in all 3 of these. So I can think of 24 as 12 times 2. I could think of 48 as 12 times 4 and 60 as 12 times 5. At this point in time, I can see if there's any other overlap. So I know like 12 is something that's going to be common here. Now, it's really tempting to think, hey, there's a 2 here, there's a 2 there, these are going to be part of the GCF. But the thing is, they're not part of that GCF because there's a 5. And the third one does not share it. And if the third one does not share it, it cannot be a common factor of all 3 of them. So the GCF is simply 12, that which is in common among all 3 of them. So when you're dealing with 3 or more terms, it has to be the same factor in all of them. Not just 2 of them, not like half of them, but all of them. All right, so now I want to talk about some sneaky stuff. So let's say we had to find the GCF of something like 3, 5, and 11. These are all prime numbers. 3 times 1, 5 times 1, 11 times 1. And if we look at it that way, hopefully we pick up on something and realize, yeah, they all share 1. And so sometimes you might think of it as like a cop-out answer, like, oh, well, the GCF is just 1. 1 is always an acceptable answer. So keep that in mind. All right. The other thing that could be sneaky is, let's say we're dealing with something like 6, 18, and 24. You start breaking them down. Hey, 3 times 2, 9 times 2, 3 times 3, and then here 8 times 3, 4 times 2, and then continue 2 times 2. It's possible for one of these numbers to actually be the GCF itself. And that's exactly what would happen. If we look at what we have in common, they all share a 3, and they all share at least 1, 2. And so the GCF could be one of the numbers itself, which is 12. So again, that's kind of sneaky. So just to recap everything, first, make sure you break everything into its prime factorization. So break into prime factorization. And 2, circle all the common factors. And common means to all of them. So not just some of them, but all of them. And you multiply the common ones together, and you have your GCF. So good luck with your homework or practice, and let me know if you have any questions.